If you find this video helpful, then feel free to donate whatever amount you can. Link is in the description below. Two circuits, the impedance of which are given by Z1 is equal to 10 plus J15 and Z2 is equal to 6 minus J8 ohm are connected in parallel. If the total current supplied is 15 ampere, what is the power taken by each branch? Find also the power factor of individual circuits and of combination. Draw vector diagram. Solution. First of all, we will write what is given. The value of Z1 is given. Z1 is equal to 10 plus J15. Now here we can see it is given in rectangular form. Now we can convert this rectangular form to polar form. So it will be under root of 10 square plus 15 square at an angle of 10 inverse of 15 by 10. So it will be under root of 10 square plus 15 square. So it is 18.02. 18.02 at an angle of 10 inverse of 15 by 10. 10 inverse of 15 by 10. So it is 56.30 degree. This is the polar form. Of Z1. Now Z2 value is also given. So the value of Z2 is equal to 6 minus J8. 6 minus J8. Again this is in rectangular form. So we can convert this into its equivalent polar form. It will be under root of 6 square plus minus 8 square at an angle of 10 inverse of minus 8 by 6. So this will be under root of 6 square plus in bracket minus 8 square. So it is 10 at an angle of 10 inverse of minus 8 by 10 inverse of minus 8 by 6. So it is minus 53.13 minus 53.13 degree. So this is the polar form of Z2 now are connected in parallel. So suppose this is Z1 and this is Z2. Let's say this is Z1 and this is Z2, both are connected in parallel, and obviously it is connected to a AC supply. This current is also given. If the total current supplied is 15 ampere, so this current value is given. Let's say this is current I and it is equal to 15 ampere. This current will be I1 and this current will be I2. Now we will find total impedance. Z total will be equal to Z1 parallel with Z2. So it will be Z1 into Z2 divided by Z1 plus Z2. So it will be, now here we are doing, for the numerator we are doing multiplication of Z1 and Z2. So we will take Z1 and Z2 in polar form. So here this is the Z1 in polar form, and then we will multiply it with Z2 in polar form. So this is the Z2 in polar form. Then in the denominator we are doing addition. So for addition, we will take the rectangular form of Z1. So it is 10 plus J15. And then we will add this with rectangular form of Z2. So it is 6 minus J8. Now we will simplify this. So it will be 18.02 multiplied with 10. So it will be 180.2 at an angle of, now this will be 56.30 and minus 56.30 minus, not minus, plus minus 53.13, and then we will divide this by, so this will be 10 plus 6, 16, then this will be J15 minus J8, so it will be 7 plus J7. Now it will be 180.2 at an angle of, this will be 156.30, not 156, only 56.30, then plus minus will be minus 53.13. So it is 3.17 divided by, now again here it is in rectangular form. Now here in the next step we are doing division. So we will convert this polar rectangular form to polar form. It will be 16 square plus 7 square, 16 square plus 7 square at an angle of tan inverse of 7 by 16. So this will be under root of 16 square plus 7 square. 16 square plus 7 square will be 17.46. So 180.2 at an angle of 3.17 divided by 17.46 at an angle of tan inverse of 7 by 16. So it is 23.62. 23.62 degree. So this will be 180.2 divided by 180.2 divided by 17.46. It is 10.32. 10.32 at an angle of 3.17 degree. It will be 3.17 degree minus 23.62 degree. So it will be 10.32 at an angle of 3.17 minus 23.62. So it is minus 20.45. Minus 20.45 degree. This is the value of total impedance Z total. And its unit will be ohm. Now we have found the value of Z total and we also have the value of total current I. So we can find the value of voltage V. So according to Ohm's law, V is equal to I into Z. So the value of current is 15 ampere multiplied by Z is, the value of impedance Z is 10.32 at an angle of minus 20.45 degree. So it will be 15 multiplied by 10.32. So it is 154.8. 154.8 at an angle of minus 20.45 degree. So this is the value of voltage V and its unit will be volts. Now we have the value of voltage V, total impedance, and we also have the value of current. Now Here we can see the voltage across Z1 and Z2 will be same because they are connected in parallel. So now we can find the value of what is the power taken by each branch. So we can find the value of P1 and P2. Let's say this power is P1 and this power is P2. So we can find the value of P1. P1 will be equal to I1 square into R1. So I1 square will be this I1 square, or we can find by using V by V square by R. Or I1 square will be, we can also find by using I1 square by R. I1 square into R 1. So I1 square will be, first of all we have to find the value of I1. So I1 will be Z V upon Z. V upon Z1. V upon Z1 into R1 and its square. The value of voltage is 154.8 divided by impedance Z1. So impedance Z1 value is 18.02. 18.02. We will take the magnitude of both of this. So it is square into R1. The value of R1 is, here we can see this is the value of R1, 10. So 10 is the value of R1. So multiplied by 10. So it will be 154.8 divided by 18.02. This will be in bracket. Square multiplied by 10. So it is 737.95. 737.95 is the value of P1 and its unit will be watt. Then next is P2. So P2 will be also same. It will be I2 square into R2. And here in place of I2 it will be V divided by Z2 whole square into R2. So V will be same, that is 154.8. 154.8 divided by Z2. Now Z2 magnitude of Z2 will be this value 10. So 10. Now it is square multiplied by R2. Now R2 will be this value 6. 6 will be the value of R2 because it is resistance. So we have to multiply this by 6. So it will be 154.8. Here this will be 6 and here in place of 18.02 it will be 10. So it is 1437.78. So this is the value of P2 and its unit will be watt. Now next we have to find what is the power taken by each branch, then find also the power factor of individual circuits and combination. So next we have to find power factor. So to find power factor, first of all again we have to find I1 and I2. So I1 will be equal to again V upon Z1. Here we can see I1 will be equal to V upon Z1. So this will be the value of voltage is, again in polar form it is this value. So we will take this value. Now it will be divided by Z1. So we will take Z1 in polar form. So Z1 in polar form, this value. So it will be 154.8. 154.8 divided by 18.02. So it is 8.59. 8.59 at an angle of, now this will be minus 20.45, minus 20.45, then minus 56.30, 56.30. So it is minus 76.75, minus 76.75 degree. This is the value of I1 and its unit will be ampere. Then next is I2. So I2 will be equal to V upon Z2. Again, the value of V1 will be same. It is 154.8 at an angle of minus 20.45 degree. Then the value of Z2 in polar form, it is 10 at an angle of this value. This is the value of Z2 in polar form. So it will be 154.8. So it will be 15.48 at an angle of minus 20.45, then minus 53.13, minus 53.13. It is 32.68, 32.68 degree. So this is the value of I2 and its unit will be ampere. Now we have the value of I1 and I2. Now we can find the value of power factor also. So here the power factor will be, we have to find power factor of each branch and combination. So first of all we will find the power factor of individual branch. So it will be, for Z1 the power factor will be phi, this will be the angle phi, 56.30. So power factor for Z1 will be equal to cos phi is equal to cos of, it will be 56.30. 56.30. So it will be cos of 56.30. It is 0.554. 0.554. Then power factor for Z2 will be cos of phi. It will be cos of the angle of Z2. The angle of Z2 is 53.13. So it will be 53.13 cos of 53.13. It is 0.6, or we can take minus. So it will be same. Then we have to find combined power factor. So to find combined power factor, the angle will be this 20.45. To find total power factor, total power factor, it will be equal to cos phi, and here the angle will be cos of 20.45. Here we can see total impedance angle is 20.45 degree. 20.45 degree. So cos of 20.45, it is 0.936. 0.936. Then now we have the value of total power factor, then current I1 and I2, then power P1 and P2, and we also have the value of voltage, total impedance. Now next we have to draw the vector diagram. Now to draw the vector diagram, first of all we have to find the angle of voltage. The angle of voltage is this, and what is the angle of current? The angle of current, here we can see it is 0, only it is 15 ampere is given. So we can take 15 ampere current as a reference. So we will take 15 ampere current as a reference. This will be the reference. Current I is equal to 15 ampere. Then voltage. Now the voltage is minus 20.45. So minus 20.45 degree. It will be like this. Voltage V is equal to 154.8 minus 20.45 degree, and V is equal to 154.8. Yes, 154.8 minus 20.45. Then next is I1. So I1 is minus 76.75. So it is also negative, and I1 is equal to 8.59. So 8.59, it will be smaller than this 15. I1 is equal to 8.59 ampere, and its angle is 76. It is 76.75 degree. Then next is I2. So I2 is positive 32.68. 32.68. I2 is equal to, the angle is 32.68 degree, and its value is, the value of I2 is 15.448. 15.48. 15.48 is the value of I2, and its unit will be ampere. Now it have I, current I, then voltage V, then current I1, and then current I2. So this is the vector diagram. This is vector diagram. Now why we have taken this below? Because this 20 was negative, that's why we have taken it downside. Also this 76.75 is negative, that's why we have taken it this side. And then this 32.68 is positive, that's why we have taken it upper side. So this is the vector diagram, and these are all the answers. If you find this video helpful, then feel free to donate whatever amount you can. Link is in the description below. Thank you.